Hi everyone, welcome to today's lesson. We're going to continue to talk about how to get zeros of the function or root of the function by looking at a graph or by graphing it on the graphing calculator. So if you can pause the video here and go get your TI-84s to have yourself ready for this lesson. So on the screen, we have a cubic function this time, not a quadratic function, a cubic function. And cubic functions always have three roots because it's cubed, right? The highest degree of the polynomial is the third power. So as you can see, we have the graph of f of x. And if you were to FOIL or to distribute this and multiply, you will get x's value, the degree of the polynomial of 3. I want you to find the zeros of the f. So I'm going to circle all the zeros here. So looking at this cubic function, we have 1 right here, and then we have another one right there, and then the third one right there. So we have -1, 2, and 3 as your zeros. Simple as that. That's it. For the next question, you will need the calculator. The graph of f of x is shown. Approximate the zeros of f to the nearest 10th. So I want to graph this on the graphing calculator actually, even though the graph is shown, just because I want to go look at the table values. Or I can use that function of doing second calc and then go to number 2 to calculate the zeros of the function. So right here, if you graph on y equals, these are my table values, x's and the y's. They are not in decimals, so I want to turn them into decimal. So what we're going to do is we're going to play with the table set of the values, the change of the table set. So let's do that. Let's go to second table set. That's what you're going to do. So second table set, or the window button, and we're going to change my table. So this is the triangle here. Change the table to 0.1. I'm going to put 0.1, not 1, but 0.1. So that my graph or my table is going by decimals. So here it is, my x values and my y values right there. Scroll up and down to see. Then what I'm looking at, and again, you can do this without going to the table. You can just do it the way that we did yesterday with the other lesson. But here is what I'm looking for. I am looking for a values or the y values where it changes signs. So do you see from negative to positive, it changes? So negative 0.11 to positive 0.24. And I'm looking at the x values of those where that change happens. Why is that? Because if you look back at the graph, my zeros of the functions, your y values always change from negative to positive, or or positive to negative. So your zeros of the function or the root of the function is always when that sign changes. So that's where I'm looking at. So that zero of the function is negative 3.7 because it's actually closer to negative 0.11 than 0.24. So I'm going to go down and scroll down to use the arrow to go down to see where another change happens because we have two roots. So, and here it is, we have negative 0.11 and then it changed back to positive 0.24. And we're going to take the closer one, which is negative 0.3. So those two are my solutions or the zeros of the function, and that's to the nearest 10th value. So negative 3.7 and 0.3. Let's do the way that you guys already know how to do. So we're going to press second calc and calculate the zeros of the function. Second calc, number 2. We're going to go to the left bound. Let's first, because my cursor is nearby that one, let's do that one first. So left bound, right bound, and then 0 is negative 3. So approximately to the nearest 10th. And then we're going to have to do that one again. So second calc, 0 of the function. Move with your arrow to the left, and we're going to go past that 0 and then click enter, move it to the right bound, enter, and guess. And the 0 is negative 3.7. So we get the same answer either or, whether you use the table or you use the second calc option. Next question is a word problem, real life application. A football player kicks the football 2 feet above the ground with an initial vertical velocity of 75 feet per second. So football kicked, and then it's going to make a parabola. That's the given equation. And it starts with a negative because we have a frown. The quadratic function is a frown. Think about a football, you kicking a football and then landing on the land. And then height is in h in feet, and then t is seconds. Part A says find the height of the football each second after it is kicked. B is use a result from part A to estimate where the height of the football is 50 feet. And I'm thinking about 50 feet, meaning it's going to reach 50 feet somewhere in the graph. And then part C, we're going to get to afterwards. So let's talk about part A first. Find the height of the football after each second, after it is kicked. So all you need to do is plug that equation into your TI-84. You can graph it by hand, but obviously it is much easier to use the graphing calculator. So put the equation into the calculator, y equals, and then I did second table again. And looking at those values, that's pretty much it for part A. All you need to do is write down in words. The height of the football is 61 feet above the ground after 1 second. After 2 seconds is 88. 3 seconds is 83, and so on and so forth. And that's actually what you're looking at. And obviously, we're not going to look at the negative values because height cannot be a negative value. So this is the section that we're going to focus on right now. That answers part A. Part B, we're going to go back to this table and look at the table values. And as you can see, the Y values are your height of the football. So after it's kicked, it's going to go from 2 to 62 to 61 to 88. 88 seems to be the highest, and then it comes back down, 83, 46, and then to the ground. So between these two is where the 50 feet, where the football is 50 feet above the ground. So you can say, based on the values of the function, at time 0, between time 0 and 1 second, my football is 50 feet above the ground. Then obviously when it goes up, so let's say I threw a football, it goes up and then it has to come back down. So that's when it's going to hit 50 feet above the ground again. Because it goes up 50 and past 50 and then comes back down. So comes up down to 50 and then goes to the ground. So that's here. So between 3 to 4 seconds, the football is 50 feet above the ground. So let's write that down. So here is the answer to that question, part B. You can pause the video here and then write down that small paragraph. Let's move on to part C. Part C says using a graph after how many seconds is the football 50 feet above the ground? H equals negative 16t squared plus 75t plus 2 and set it up to 50 because I want to know where that equation of that football traveling equals 50 feet above the ground. So the very first thing that I need to do is I'm going to move over the 50 to make it equal to 0. Subtract 50 on both sides, and then you get negative 16t squared plus 75t minus 48 is equal to 0. Then I'm going to put that equation into my calculator. Negative 16x squared, or t squared, same thing, plus 75x minus 48. So this is the graph I get. I'm going to look for the zeros of the function, which is second calc, number 2. And I'm going to need to find my cursor, so just move slowly, and you see that it's moving a lot quicker. So I'm going to do left bound, right bound of that 0, and I can round it to 0.8. Let's round to the nearest 10. So that would be my one of the zeros where my football will reach 50 feet above the ground, 0.8 seconds. And then it'll also reach, we're going to do that again, second calc, 0. Go to your left bound, which is, you have to move with the right arrow all the way around. And left bound, your x value is smaller than the right bound x value. So enter, enter, enter. You get 0 of the function is about 3.9 seconds. So football goes up, hits 50 feet over the ground, 0.8 seconds after it's kicked, and then it comes back down. After 3.9 seconds, when it comes back down, it hits 50 feet above the ground again. That's all for today, and I hope that this made sense. If you have any questions, make sure you reach out to me. Good job, and I'll see you guys in the next lesson.